Morning. Good morning, good morning. 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 How's it going? How's it going? How's it going? How are we this morning? Y'all ready? Get ready on our task this week. Y'all are moving right along this week. Now all we have left is the application task. You've already done the first two homeworks. Hopefully you're kicking out that assessment quiz, and then you can start on your application task, or maybe you want to do the task first and then the assessment quiz, whatever. Morning, Jasmine. Morning, Kelsey and Zoe. We're going to have a little fun today. I'm going to tell you about the game you're going to make. We're going to get started here. I'll tell you about the game you're going to make. Good morning, Courtney. Good morning, Ankara. Got this week going. Hey, Bo. It is bright and early morning, well, mid-morning. My plan today is to go on a picnic. I'm going to take my daughter on a picnic. We're going to get some takeout, take a table and chair down to the park and stay away from everybody in a separate little place and have a picnic. She wants to have food out today. And since she's been isolated and quarantined from the rest of us down with her grandfather, she's doing a good job taking care of him. I'm going to reward her. That's the plan. Little picnic. It's supposed to be a gorgeous day today. Pretty. Like 80 degrees, almost 90 degrees today. My kind of weather. We're finally getting there. Of course, it's only today, and then tomorrow it's supposed to get nasty again, or at least cold again. Hey, Haley. Way to join us. Glad to see you. Glad you're here. Woof. So, y'all are going to get to make a board game. Don't these look fun? Some fun board games going on. We're going to have some fun with some board games. So I'm going to tell you this morning, hey Giselle, I'm going to tell you this morning what to do, what not to do on your, that is learning to ride that bike, getting to ride your bike, man, that's my favorite thing to do is ride bikes. Thanks. It's a game. I made a game. I created a game with our things around the house. And you know, part of the game, you have to be able to fight. My kids every year from Santa got a new Nerf sword. Everybody else was into Nerf guns. We were never into Nerf guns. It was more the swords / maces / you name it. That was the fun thing to do. And then they'd kill each other around the house. We have a few holes in doors and broken pieces of the house because of the sword fights around the house. Fun times. All right, I think we got pretty much, y'all are here. So here's your task this week. Your job is to make a board game. So I've got two different games here. I've got foot race. This is one game, nice and simple. We're going to start, and you can either start, it's two versions of the game. You can start here and finish and be done, or you can start and finish. So it could be just a there game or a there and back game. So there are 4 different people who can play the game. Or we have, I have Swift Mages, and in this game, the mage's job is to make it here to the middle to defeat the evil sorcerer. So they've got to make it to the evil sorcerer to beat him. So we got on both ends. So two different games. So your job is to create some, you come up with your own. What do you want your game to be? So come up with some game and just use things around your house. So you could use, this is just done on paper, just drawn off on paper. You could use, like, we've got Amazon boxes where, that's where this came from, is cutting off the cardboard of Amazon boxes now that we're ordering everything online. Or maybe just paper is fine. Whatever you have around the house to create your board game. And then, creativity is great. That's always encouraged. Morning, morning, morning. And then you've got to come up with a way to move. So, here I have a spinner. And then, and we'll talk more about the spinner in a little bit. And then on this one, I got a little fancy. So probably keeping it with a spinner or something where the probability stays the same is going to be important. But in this one, I got a little fancy and have these little cards that you could pull out. We got our little flags for the race, the checkered flags to pull out. So, but we're going to talk about the do's and the don'ts of it, okay? So things you want to do and things you don't want to do when you're creating your board game. So as you create the board game, you want to think about that expected move. That's the whole idea here, is you want this game to be something you play and is enjoyable, but at the same time doesn't last all day long. So it might help you to figure out the expected value of your whatever it is to help you move before you get started, before you actually make the thing. So for instance, let's figure out the expected value of both of my games, and I'll tell you as I was doing it, some things I thought about as I did it. So first, let's start with the foot races one. So notice it doesn't have a whole lot of spaces on it, and in fact, it only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 if I'm going just one way. It'd be 20 if I went there and back. So, it's either 10 spaces or 20 spaces, just depending on how much time you have to spend with your kid. So, and that's another thing. Especially if you're quarantined at home with kids, think about your audience of who it is that you're building that to play with. Because you are going to play the game with somebody. So, if I had kids at home, and especially if I was like homeschooling them, having to do some math with them, maybe I want a game like this to work with. But if I've got, I don't know, older kids and I'm just trying to entertain them, then maybe something like this is more appropriate. So think about who you're going to play with, and then who your audience is. Okay, so in this one, I've got some different math problems on each one of my sticks. And I went ahead and did the math. Like this one says 10 minus the absolute value of -8. Do y'all know what that's equal to? What is 10 minus the absolute value of -8? I bet y'all can figure that out. Y'all got this morning? 10 minus the absolute value of -8. I won't make you figure out all of them. Just do that one. What's 10 minus the absolute value of -8? Show Mr. Simpson I've taught you something this semester. Oh yeah, I like it as 2, because the absolute value of -8 is just 8, and then 10 minus 8 is just 2. So all of these flags are actually equal to 2. If you do the math on them, they're all equal to 2. So there's 1, 2, 3, 4, 5, 6, 7, 8 of those. 8 flags that equal 2. So what you do for this game is you pull out a stick and you figure out the math, and then that tells you how many spaces you're going to move. So in this case, I'm going to move 2 spaces if I pull out any of those 8 flags. So I'm going to put those 8 flags in my little water bottle. Those 8 flags go in my water bottle. All right, let's figure out how much these guys are. So here, this one is -3 plus 1 plus 6 minus 4. Let's figure out how much that is. So -3 plus 1 plus 6 minus 4. How much is that equal to? -3 plus 1 plus 6 minus 4. How much is that one? Or if this one's easier, they're both the same answer. -4 times 4 plus 2 times 8. Those two things are the same answer. Yay! It's 0, because this is -7 plus 7, which is 0, or -16 plus 16, which is 0. Yay! So I have two flags that are 0. So if we get those, we don't get to move. We don't get to move at all. Then here, let's see, let's do this one. Square root of 16 minus the square root of 25. What's the square root of 16 minus the square root of 25? Or maybe you prefer this one better. -7 plus 3 plus 3. Either way, -7 plus 3 plus 3. Or, hey Eve, or the square root of 16 minus the square root of 25. Yay, -1. So if we get either one of those, we have to go backwards 1. We got to go backwards 1 on that. So there are two flags that are backwards 1. All right, two more different options here. So 15 divided by 3 minus 8 divided by 2. So 15 divided by 3 minus 8 divided by 2. It is real. It happens. It's a true statement. 15 divided by 3 minus 8 divided by 2. What? That's 1. So I have two flags that are 1. So if we get either one of those, we get 1. Y'all are doing great. I commend you. You've learned the developmental part of this class. Y'all got this basic math down. Good job. Super proud. Big steps, big steps. Okay, one more. 2 minus the absolute value of 6. Ooh. 2 minus the absolute value of 6. I don't want to get that one. Or -9 plus 3 minus 2 plus 4. So it turns out there are two flags. You're going to tell me yes, that equal -4. Yay. So if I get either one of those, I have to go backwards 4 spots. Okay, so as you're creating your game, what you want to kind of do is decide what you want your expected value to be, and create a probability distribution. You know, in order to find that expected value, you want to create your probability distribution. So here, I'm going to create a probability distribution. We're going to find out what my expected value is. So the first thing we have to do is figure out the different outcomes. And notice that my outcomes, I've got some where I'm moving forward. So 1, 0, 2 are my moving forward. And I have some where I'm moving backwards, a -1 and a -4. So I'm going to put those outcomes as my first step. Now you don't want those outcomes to be too complicated. You really want them just to be, you know, some positive values and some negative values. You don't want it to be too complicated. So mine's too complicated as it is. All right, so I'm gonna put all these values on there. So I'll just start down here. -4, 1, -1, 0, and 2. And then I need the probability of each of those. And in my game, I'm going to take one out, look at it, then I'm going to move that many spaces and I'm going to put it back in. If you do something where you make cards or you do something where you're drawing like this, you're going to want to do it with replacement so that your probability stays the same each time. Because the minute you're doing it without replacement, all of a sudden the probability gets too complicated. Excuse me. So don't do something where you take it out and leave it out. Because then all of a sudden it gets super complicated. Then you've got to start looking at all those different ways that you can pull it out. And that's just too complicated. So I'm going to advise you, in your game, whatever it is, do it with replacement. It's just going to make it easier on you. And on me too. So this game, just make it so the probability stays the same each time. So whether it's cards, you shuffle it each time or you pull something out. Probably the easiest thing to do would just be to make a spinner or to make some sort of dice where you're rolling each time it's the same probability. Okay, so here I'm going to find out the probability of each. So what is the probability that I get a -4? How probable is it that I get a -4 out of here? When I'm drawing it, what's the probability that I get a -4 out of there? What do you think? How am I going to find that out? That's the hard part. What is the probability that I get a -4? Oh, good. It's 2 flags out of the total of 16 flags. So you're exactly right. 2 out of 16, or Jasmine just said 1/8. Good. I didn't make my chart quite tall enough. So 1/8. What's the probability then that I get a 1? What's the probability I get a 1? It's that same thing, right? It's just 2 out of the 16, so it's still 2 out of 16 or 1/8. 2 out of 16, 2 out of 16. Then what about this? What's the probability that I get a -1? Well, it's again 2 out of 16, so it's still 1/8. So 1 out of every 8 turns, I would expect to go backwards 1. And then what about the probability I get 0? What's the probability I get 0? Good, it's the same thing, 2 out of 16. So far it's pretty boring, they're all the same. 2 out of 16, or 1 out of 1/8, that I go 0. Okay, last but not least, now this one. What's the probability then that I get to move forward 2 spaces? What's the probability I get to move forward 2 spaces? It's 8 flags out of a total of 16. So yes, exactly, 8 out of 16 is equal to 4 out of 8, which is also equal to, yeah, 1/2. But I like leaving it at the 4 out of 8 just so they have a common denominator. That's probably a smart way to do it, just so they have a common denominator on there. But you're right, it's also 1/2. Okay, now when I was getting ready to create this game, when I got ready to make my little sticks, I did this part first. I decided first how many of each I wanted and what I wanted my probability to be. And it helped me decide by doing this, because it was 1 out of 8 that I was doing it, I knew that the number of these I needed to make needed to be a multiple of 8. Either 8 or 16 or 24, something so that it kept my probability along with that. It made it easy for me to find the probability of them afterwards. So I started with this. And then I made sure that that was moving in a positive direction. You want your expected value to be positive, because if you end up with it negative, the likelihood that it's very probable then that the game never ends. In fact, you just keep going backwards. You don't want that to happen. You want your expected moves to be moving forward each time. So I would actually start here and then build from that. And that's what I did when I was creating this thing, is I first did some of this and I played with it to see until I got what I wanted. So here, now, to find the expected value, of course, all we do is take our number of moves and multiply it times our probability. So on this one, we move backwards 4 spaces, and our probability was 1 out of 8. I bet you can tell me what the expected move is. See if y'all can come up with what is the expected move for this game. How far do I expect to move each time? Y'all done that homework now, so now you know how to do that. I'm going to do it here as you do it there. We'll see if we get the same thing. See if you can beat me to it. All I'm doing is taking my expected moves times the probability of each one of those. They all have that nice common denominator right now, so I'm going to leave it, just multiply across. See if you're getting the same thing I am. Let's see. This plus 1 and that minus 1 becomes 0. That's a 0. So that just leaves me with 8 minus 4, which is 4/8, or 1/2. Oh yeah, there you go. 1/2. It is probably, too small. So that means on average, I'm just going to move half a space each time. That's what that says, on average. Now there's not a half up there. I'm never going to go half a spot. But on average, we're just going to go half a spot. So if on average I'm going to go half a spot, which by the way, what I did when I was creating the game was I started here. I said, what do I want to do? And I just started making up some things. I was like, what if we move backwards 5 and go forward 3 and go backwards, 2 and go forward 1, and let's just make our probability. I was just making stuff up in the beginning. And I multiplied it and I saw what my expected value was. And then once I got one that I was happy with, then I used that. So once I got one that, okay, I don't like this one for whatever reason. It was negative, or this one was too little, or this one's too big, or whatever it was. Once I got to that, then I made this, and I said, okay, well, my probability is 1 out of 8, so I need at least 8 sticks, and one of them to be that -4. It's positive because look, my 8/8 is positive, but my -4 is negative. So this one's bigger than that one, so it ends up being positive. So, it's 8 minus 4, so I end up with a positive 4. So that's the reason it ends up being positive. These guys became, this was a positive and a negative, so they became 0. But this positive 8 and that -4, he's bigger. So that's why it's positive. So I would start here, play with it, decide on your expected value, and decide what your moves are going to be, and then what your probability is going to be. Then, if you do something like you have -4, and then that probability is something like 1/4. Then, if you're making a spinner, then you need to have 4 pieces to your spinner. If you're making a die, then you need to have 4 pieces to your die, 4 sides to your die. If you're doing drawing cards, then you need 4 or 8 or 12 or 16 cards. So this bottom denominator helps you decide on the number of things that you're doing it out of. So I would literally start with the probability distribution, come up with your expected value first, and then from that, decide on your moves. So I have 16 little flags because that was a multiple of 8. And then I figured out from there, well, if I want 16 flags and it's a multiple of 8, well, that multiplies by 2, this multiplies by 2. I need 8 of my flags then to be 2. Then I started the creation of the whole thing. All right, so your job is to create that probability distribution, tell me what your expected value is, and then create a board. Now, I need to know how many turns should I finish in. So that's the next part of it, is to figure out then how many turns should I finish in. So if I'm just moving half a spot each time, if I'm just going half a spot each time, and there are 10 spots on my board, how many moves should it take me? How many moves would I expect this game to take? So this is my expected movement, 1/2 space on average. That's what that expectation is. Good, Aunt Kara, that's exactly right. If I'm going half a thing each time, then I would expect to finish the game in 20 turns. So I expect to take 20 turns. What if I were going there and back? Then how many turns would it take? If I made this game, I'm like, we're going to play the long game today. Let's do there and back. Then how many would it take? Yeah. You got this. You got this now. That's what doing that practice ahead of time really made a difference. Good, it's 40. That's exactly right. You just double it to go there and back. So you can decide, I decided on a half because I had this little bitty board. And I was like, okay, 20 turns is not an unreasonable amount of time to play. I could play with some kid for 20 turns and finish. And we might finish faster. It might take us longer. Because just because that's what we expect to happen doesn't mean it's going to happen. But that at least gives me an idea of it. Okay, so these are the things you're giving me. You're giving me this probability distribution and your expected value. You're going to have to do the game and tell me how many turns it's expected to be. Then you're going to empirically tell me what happens. So in other words, you're going to actually have to play your game with someone. So find somebody you're quarantined with that you can play with. So if you have a child in the house, this is a time where you get to spend time with your child. And then, but if you don't, if you've got a parent in the house, then this is a time that you wrangle them and you say, okay, I'll wash dishes if you'll play this game with me for stats. Or if you're home alone and you're just isolated completely, then virtually you're going to get to connect with a friend via Facebook Messenger or Skype or something. Get on Discord and play the game. But play the game, or you can get out a stuffed animal and you can play with your little stuffed animal, something, but you're going to actually play the game. Okay? Find somebody, your dog or your cat, somebody you can play the game with. And then you're going to actually play it. So let's do let's do it and let's see. Yes, that's the whole reason, Priscilla, is just so you can spend some time with her. Your imaginary friend, whoever it is, that's there, y'all play with them. Okay, so let's just do, and here's what I want you to do as you play the game. So, if I play the game, oops, I didn't bring a magnet in here. Man, I'm so prepared, and then I don't have my pieces. Oh, no, I put it all away. Darn it. Okay, so I'll play the game. I got it. Got this. Okay, so we'll play the game. I'll let y'all play with me. So I'll draw first. Destiny, you gotta have a stuffed animal or a Dr. Pepper can. Here, I'm gonna play with my Dr. Pepper can here. Okay, Dr. Pepper can and I are gonna play. Hey, Dr. Pepper can, I'm gonna beat you at this game. I'm gonna race to the finish. I'm faster. I've been training. I'm gonna beat you. Okay, so here we go. So I'm gonna pick something. Here's mine. I got 5 minus, or square root of 25 minus the square root of 9 is 5 minus 3, which is 2. I get to move forward 2 spots. So I'm going to go forward 2 spots. 1, 2. Okay, so me, on my movement, I went forward 2 spots. Now, DP, he gets to draw. So DP draws, and he has to figure out the math. Negative 12 divided by 6 is negative 2, plus 4, 20 divided by 5 is 4. So negative 2 plus 4 is 2. He too goes forward 2 spots. Right now we're in good shape. So DP went ahead 2 spots. Now I get to go again. Negative 9 plus 3 is a negative 6. Minus 2 is a negative 8. Plus 4 is a negative 4. Oh no! I went backwards 4. Oh no! Back to the beginning. Oh man. Oops. You know what I'm not doing is putting it back in. Everybody needs to put it back in. It's true. The quarantine has made us go crazy. Okay, you get the idea that what I'm going to do is actually play the game all the way through. 20% times 10. What's 20% of 10? It's just 2. Dr. Pepper gets to move ahead 2 spots. Oh, put it back in with replacement. Then pull it back out again. Yeah, it is with replacement, Jasmine. I should have been putting it back in. Negative 7 plus 6 is a negative 1. Oh no, I have to go backwards again. I can't go backwards. I'm already back at the beginning. Put it back in. Pull it back out. 10 minus a negative 8, the absolute value of negative 8. So 2. Dr. Pepper is winning. He gets to go ahead at 2 again. 1, 2. Oh man. Okay, my turn. 2 minus the absolute value of 6. Oh, I have to go back 4 again. Oh my God, this is horrible. Stupid Dr. Pepper is beating me. Dr. Pepper gets negative 12 divided by 6 is negative 2, plus 20 divided by 5 is 4. So 4 plus a negative 2 is 2. He gets to go ahead 2 again. 1, 2. Oh my goodness. Why am I losing so badly? Negative 5 plus 6 is 1. Plus 1. Yay! I get to move ahead 2. Yay! Can I catch him? Maybe he'll go backwards this time. Maybe he'll go backwards. Negative 7 plus 6. He went backwards 1. He went backwards 1. I'm going to catch up to him. I'm going to catch up to him. Hey, my turn, my turn. 15 divided by 3 is 5. Minus 4 is 1. I get to go forward again. I get to go forward again. Yay! Oh, he keeps getting the same one. Negative 12 divided by 6 is negative 2. Plus 4 is 2. Oh, he's going to beat me. Oh, I get to go forward 1. Oh, no. He's almost there. I need something that says, like, jump to the finish. 4 minus 5. Oh, no. We're backwards again. This is horrible. This is, by the way, this is just me. Every time I play a game, I lose. I don't care if I'm playing against the Dr. Pepper kid or not. This is what happens. My luck is just that way. See, I'm going to draw out another one. 16 divided by 4 is 4. Minus 3 minus 1 is 2. So 4 minus 2 is 2. We won! No! Congratulations, Dr. Pepper. Good game. Good game. Good game. Here. Definitely good game. Good game. Okay, so let's just look and see what actually happened then. So we said that we were going to move and it should take us 20 turns. But really it just took us 1, 2, 3, 4, 5, 6, 7 turns. It only took us 7 turns. So that's what happens when you play against me and I lose. So then let's look at what in empirically, then what were my outcomes? Notice that empirically my outcomes didn't match what happened theoretically. So here empirically, here's my empirical data. Empirically, I only got a 2 or a negative 4 or a negative 1. Those were my only outcomes. 2, negative 4, negative 1, oh, and 1. I did get to go forward 1. And then empirically, what was the probability that I got a 2? So empirically, what was the probability that I got 2? 1, 2, 3, 4, 5, 6, 7, 8. We had 8 out of a total of 1, 2, 3, 4, 5, 6, 7 doubled is 14. So yeah, 8 out of 14, or you're right, that's just equal to 4 sevens? 4 sevens, right? Isn't it 4 sevens? Oh, I see. I'm counting them all, every one of them, so that I get 8 out of 14. Yeah. Yeah, if I were just looking at my data, you're right. It would just be 2 out of 14. But out of the whole game, you're right. Maybe if we just look at Dr. Pepper, since he's the one that finished, maybe I should just be looking at Dr. Pepper since he's the one we finished. But we collected this data, and we have how many spaces we went out of those turns. And so we know that it was 2 out of the 14 turns that we took. Then, just the total. And then the negative 4s, well, there were 1, 2 out of those 14. I'm just going to leave it at 14 because here in a minute I may need it to be to 14. And yeah, Mr. Simpson's right. The larger the sample size, the better. Then the negative 1, well, we went backwards 1, 2, 3 times, so 3 out of 14. And then forward 1, we just got to do once, so 1 out of 14. So empirically, yeah, poor 0, he didn't get any. So now empirically we just multiply the outcomes times the probability. The outcomes times the probability. So we end up with 16/14 minus 8/14 minus 3/14 plus 1/14 for a total of, let's see, that's 8 minus 3 is 5 plus 1 is 6. I got 6. Well, y'all check me to make sure that's right. Or simplifying, that's 3/7. So according to this, we actually did the expected value of the expected move was 3 out of 7 rather than that 1/2 that we got. So empirically, whereas this is in theory. So notice the theoretical doesn't match my empirical. Now, if I were to play this game more and I kept collecting data over time and collect a lot of data, then my empirical should match my theoretical. So if I keep playing this with Dr. Pepper every day and we keep collecting our data, then our empirical should get closer and closer to that theoretical. So that was a fun game. So that's exactly what I'm looking for. I want you to come up with, what's your expected outcome. I would do that first so that you're making sure you're actually moving forward and not going backwards. And then create your game around that. So there's the nice, easy foot races. And instead of using the spinner, I just made little checkered flags. So you could do something like that, make like cards or something that you're drawing. But if you do, the big deal with that is make it with replacement so that the probability is not changing each time. Otherwise, it just gets too complicated. So don't try to make this complicated. I don't want to make it complicated. It's complicated enough as it is. Then my Swift Mages game. In this one, I used a spinner. So in this one, we've got Swift Mages here. And on it, it's not a board game, rather I just use things I had around my house. Y'all all have toys like this around your house, right? When your kids are all grown. You've got cool little pieces to play with. I mean, this is fun stuff. Oh yeah, we know how to find that sampling error, Mr. Simpson. We know that we do our observation. You remember, guys, how to find the error? You do our statistic or our observation. So the statistic minus what was expected. Our observed minus our expected. So we observed the 3/7. The parameter, or what was expected, was 1/2. And then that difference is the error. Do you remember finding that? We did that earlier. Yes, I do. Creativity will definitely get you bonus. And then also you're going to video yourself playing the game. And at least some of the rounds. You don't have to video the whole thing, but video some of the rounds, and then you have to send me the video, but then post it somewhere. Put it on TikTok, put it on Snapchat, put it on something where you can tag me, Instagram, and you get bonus points for tagging Simpson Math too. Yeah, that was a long time ago, wasn't it, Bo? The first month we talked about error, the difference between the statistic and the parameter, our observed minus our that happens over and over again in statistics, where we're looking at our observed data minus our expected data, and it gives us some outcome. Yeah, tag both push that rock and Simpson math. I'll give you a point for each of them. He likes to get stuff too. I know, why aren't you taking part in my social media? Good grief. Let your friends know what you're doing in math and how much fun it is. Look, we're trying to build our brand. If they don't know about us, how can we build our brand? And while you're here, like us and subscribe. Tell your friends about us. Okay, now I'm going to play my Swift Mages, or let's just look at my Swift Mages. So the Swift Mages game is nice and simple. First you get to choose your pieces, and then your job is just to get to the Dark Wizard so you can defeat him. So, you know, really it looks complicated. This game looks really complicated, but it's not. It's super simple. I'm just moving my mage from here to the Dark Wizard. Or on this end, I'm just moving my mage from there to the Dark Wizard. That's all I'm doing. Nice and simple. So it looks complicated, but it's not really. Okay. Then I just created a spinner that's always going to go down while I'm holding it up. But if I fold it flat, it actually works. And the choices are entangled, lose this turn. So if I'm losing this turn, I'm really moving 0 spots. So, you know, you read that and you go, okay, that's really just 0. I'm not moving anywhere. You can't see the board? You can't see my board? But it's such a cool board. Here, I'll move it up just a little bit. I don't know that it'll help though, y'all may be too, oh, it's because of this. Let me move this down. See if that helps. Ah! Probably not. Probably mess things up even worse. I don't know. We'll try and see. So there's my board. And so all you're really doing is moving the mage to the Dark Wizard. But it's got some cool stuff in here. So we get entangled, we lose this turn. So, you know, the vine gets us somehow, and we get entangled. Then we lose our turn. And of course you gotta like use the actual themes. It makes it so much fun. And then this one, pact with demons, go forward 2 spaces. So you know you get to choose a demon, make a pact with them, and you get to move forward 2 spaces. Then a treant guide your path, and you get to go forward 3 spaces. So treant guide your path, and you get to go forward 3 spaces. Here, a spider approaches, so you run back 1 space. So, you know, when the spider approaches, you have to go back one space. I know how y'all all feel about spiders. And then you get attacked by rats, but you're saved by a marauder, so you get to go forward 1 space. So, you know, the rats are attacking you. But a marauder comes, and you get to go forward 1 space. I had a little help in my little descriptions, and my son thought that we should encourage pact with demons. So therefore, we're moving 2 spots forward with the demons. So it's because I created this game with my kids. See, that's what you're supposed to do, is spit, I don't know, what would you say that word is? It's not a marauder? I don't know. I had a little help. Okay, so basically what I'm doing here is I'm just going to move 0. I told you, you're supposed to include your kids in this, or other family members. So see, that's what I did. We've already played the game. We had some fun killing each other. So as we were attacked by rats and whatnot, we got to attack, and we saw the spider coming, and then we ran away. This is what we did last night. We had some fun. This is quarantine time, let me tell you, when you're quarantined in the house. So, you know, I don't know. Okay, so here we go. This is really just 0. If I lose a turn, here I'm going forward 2 spaces. There I'm going forward 1 space. I'm running back 1 space, so running back 1 space is that -1. Yeah, well, the pirate helped us this time instead of hurting us. And then he killed the rats instead. And then the treant moved us forward 3 spaces. So those are my outcomes. And then the probability of each outcome. What is the probability of each outcome? Oh, you're right, I have to write lower because I moved my camera down. Thank you. Can you see that? That's right. I like it too. See, look at him. There's one, but there's more than one. There's another one. There's another one. Lots of different pieces. Lots of pieces to play with. Okay, so now what is the probability that I get 0? What's the probability that I get 2? What are those probabilities? It is true. I had a lot of fun creating the game, and I was up way too late doing this. I should have been in bed, but instead I was having fun with stats game. That's what I want y'all to do too. Have some fun with it while you're doing a little learning. That's the whole plan. That's what you're supposed to do. So good. 1/5 is my probability because there's 5 equal pieces. 1, 2, 3, 4, 5. So each one of these is just 1/5. So you can see on the spinner, it's nice and simple. My probability is just the same for each one of them, nothing complicated about it. Or if you were to make a dice, that would be the same way. You know, you make a die and put your little movements on it, then that could be nice and simple too. By the way, I was tempted in this game to do something on the board like go back to your starting spot. That's a temptation, right? We've seen that in games before where you say go back all the way. But that changes your outcome. Like when I go back, am I going back 1? Am I going back 2? Am I going back 4? All of a sudden, again, that's too complicated. I don't want you to do anything too complicated. So try to keep it nice and simple where your outcomes are just things like 0, 2, 1, -1, 3. You know, it's not too complicated. Notice my outcomes here are not too complicated. So it is tempting when you're making the game to do something like that. But just keep it nice and simple. Keep it nice and simple. Think Chutes and Ladders or Candyland. You know, don't think Sorry or Monopoly. Nice and simple. Okay, so then we just find the expected value of it. And the way we find that expected value is just multiply. 0 times 1/5 plus 2 times 1/5 plus 1 times 1/5 minus 1 times 1/5 plus 3 times 1/5. And then you just multiply to find that expected value. So 0 plus on average, what's going to happen? So I've got 3 minus 1 is 2 plus 3 is 5. So 5/5. So on average, I should move forward 1. So notice in this game, on average, I was just moving forward 1/2. But on this one, on average, I'm moving forward 1. And this one only has 1, 2, 3, 4, 5, 6, 7, 8 spots on it. So if I'm moving forward 8 spots, how many turns should it take me? Good, Jasmine, you've got this. How many turns should it take me if it's just 8 forward 8 spots forward. Yeah, should just take 8 turns. So that's right. That's exactly right. Just 8. It's nice and simple. So this is your job, and my advice is start here. Start with this. Decide on your numbers and your probabilities before you begin. Maybe you can visualize, okay, I want to do a spinner. What would be a nice way to break it up? So what would my probabilities be? You know, think about it ahead of time and decide on your expected value first. And you want your expected value, well, it depends on how long your board is. You know, if you've got 100 spaces on your board, then for sure you want your expected value to be a little bit bigger. But if your board is little, then you're going to want your expected value to be something little. So think about all that when you're creating it. But start with that expected value. And then create it, and then play it with someone. And when you play it with someone, document each turn what your outcome is, and then find the actual empirical, the empirical one. Your empirical average, your empirical probability. All right, y'all got this idea? Is it kind of making sense? Make sure you're doing your probability the same each time, and then don't make it super overly complicated. You think you can do it? Okay, now the plan is we're not going to stream tomorrow. Tomorrow on Thursday, we're not streaming. I want to give you time to do that board game, and then also to spend time with family playing it. So no stream tomorrow, and then I'll see you back on Monday morning. We'll start with some Bayes' theorem. There is going to be an assignment coming that is in preparation for next week. So you need to watch for that upcoming assignment. I'm going to put it in Dropbox. I'll email it to you. I'll put it on Discord to make sure that you get it. It's going to be due before like Monday. It's going to be due like Monday, so that you're prepared for next week. You're already starting to think about next week. So just be prepared for that. I know we don't get to see each other tomorrow, but you're going to have fun playing your game. And I can't wait to see the videos of y'all playing your game. So, and then watch for that preview of week 4, because I'm going to give you a pre-assignment so you can start thinking ahead of time about it. And I will be in Discord all day tomorrow. So if you need help with something, if you're like, this board game's not working out, I don't understand what I'm doing, I'll be here. If you're still working on your homework, I'll be here. It is true we can't see each other that way. It's not quite the same. Even this is not quite the same as classroom, but it's not too bad. It's better than not doing it at all, I guess. All right, y'all have a great afternoon, and we do this. Math Made Simple at Simpson Math. Thanks for watching. I'll be on Discord too. Oh yeah, don't forget the assessment quiz.